Where do you get your virtual ECU from? In the future, that will be functional mock-up units. And people like Benedikt from dSPACE, whom I'll be interviewing, will still be working on the FMI standard at the moment with the layered standard bus. And that's being released in version 1.0, and that's why Benedikt will explain what the layered standard bus is, how it works, how you benefit from it, and what you need to do to start using that. Hello everybody, welcome, and we are starting today with the topic of FMI-LS-BUS, so functional mock-up interface layered standard buses. And I'm happy to talk to Benedikt today, and he's been our local expert on the topic of FMI and those layered standards for a long time. Welcome, Benedikt.
Hello, Felix.
So would you like to introduce yourself?
Yes, my name is Benedikt Menne and I'm working now for over 13 years at dSPACE. I started as a software developer at the product system list, where you can export VECUs, and concentrating there on working on basic software code generators and the general integration of VECUs. And now I'm working as a product owner at our simulator VEOS.
Thank you. And yeah, FMI, layered standards. Let's talk a little bit about FMI as is. So could you briefly explain what FMI is?
So at least FMI is a standard where you can describe how you can simulate and exchange simulation models in general.
Okay.
And the FMI standard itself, since version 3.0, gives you the possibility to define something that is called layered standard. So you can define a standard based on the top of the original FMI 3.0 standard, and then you can focus your own problem domains. For example, bus communication or something else, whatever you want.
Okay, and you've been using the word virtual ECU, VECU before, and now we're talking about simulation models. But in the end, the FMI 3.0 also makes it possible to create virtual ECUs as FMIs, right?
Yes, yes. So what we are doing here is we pack the ECU code inside the FMU and simulate it there. Yes. So we are using the FMI standard to simulate the VECU itself. So as a kind of medium.
And by that we now have a standard that can be used to describe a virtual ECU.
Yes.
Which is of course already nice. and then we have layered standards.
Yes.
So what are those?
So that layered standard, as I already mentioned, is a standard that is built on the top of the FMI 3.0 standard. And here you can focus your own problems. For example, the FMI standard itself does not specify or know something about network communication. And now we have the possibility to define a layered standard which is using the FMI functionalities, for example, like clocks or binary ports or co-simulation, whatever you want, in the FMI 3.0 standard. And then you can define how the network communication can be modeled and simulated within FMUs.
Okay, so instead of just creating a binary port, which I know has some bus data in it, I can also describe how that bus data looks like, so more things can be done with it. Is that the general idea?
Yes, yes.
Okay, so are there other layered standards on top of the LS-BUS that we will be talking about?
Yes, from dSPACE side, also with other big companies, we are working on the layered standard for XCP, which allows the XCP communication or using the XCP protocol inside of FMUs.
Okay, so but then now we're talking about the layered standard bus, because the layered standard bus has a first release upcoming.
Yes.
So When's the release?
The release was for, I think, 2 weeks.
Okay, so it's out now.
It's out now. Yes.
Great.
It's released.
Great. And then, yeah, so tell me more about the layered standard bus. What can it do? How does it work? What should I know?
Yeah, the layered standard for network communication. Firstly, I think it's the first standard which is doing this, is a standardized way of how you can handle network communication with several FMUs. So how you can handle this, and this gives the opportunity that you have the possibility that you can exchange VECUs from one ZIL product, maybe created from ZIL vendor 1, and you can simulate it in simulation environments of other ZIL vendors. So this is really a big opportunity, or a big revolution, I think, for users of ZIL products itself.
And what's inside then? How can I imagine this layered standard? I don't know. Are there descriptions of the datagrams on the bus inside? Is there priorities? Do you put a K-matrix in there? Auto.xml files bundled? How does it work?
Okay. You primarily have 2 abstraction layers. So the first one is the physical signal abstraction layer, or called high-cut, which fits for every bus. And this is concentrating primarily on the exchange of data. For example, when you want to test in a very early development stage such your application software, so which is a very high level in your virtual ECUs.
Okay, maybe one question. How is a high-cut different from signal-based communication between FMUs without the layered standard?
So everything is about that kind of interoperability. So you have a described interface which every product, for example, every simulator who wants to support this FMI-LS-BUS knows about. So you can, for example, produce from different exporters, you can produce VECU FMUs with bus support, and then you can combine it in a general format which is specified. So I think...
So what I understand or guess is that then the FMI-LS-BUS specifies more possibilities to describe the interface of the data than the pure signal base.
Yes.
And thereby allows a better matching between 2 FMUs that want to access that data, so they can see, oh, it's the same element. Is that something that's in there?
Yes, because you have a standard which tells how the interface looks like.
Okay.
So yes, and then you are, as a user, you are able to combine it. So, and also a software vendor is able to fulfill this interface and can just provide a solution just for simulating such things.
Okay.
Doesn't matter where it comes from. Yes.
But there it's still, here's an integer, and that integer represents a temperature.
Yes.
Okay, understood. And then there's low cut.
Yes, there's a low cut. This is the second abstraction level. And this is primarily when you need to simulate very precise buses. So, for example, when it's about simulating the transmission timing, such features like arbitration and something like that, doing injection of a failure injection, for example. So it's you are able to simulate or describe bus-specific behavior, and you can test it for sure.
So what I understand is then there's a description of something like this. Virtual ECU has a CAN interface. That CAN interface receives the following ID. That's where it's interested in. And then everything, in essence, I need to feed to a CAN simulator, for example, so that it can do its job and simulate the actual network traffic below?
Yes.
So that's the general idea?
Yes, this is the general idea. Yes.
Yeah, sounds nice. Sounds actually good. And I assume CAN is supported?
Yes, CAN, CAN-FD and CAN-XL on the low cut. That's, I think in the automotive world, everybody has a long time and much experiments on CAN. And so we decide to start with CAN.
Okay.
And then expand the layered standard to other automotive buses like FlexRay, like LIN, or like Ethernet. And in the future, maybe also to non-automotive buses.
Okay, so version 1 CAN, CAN-FD, CAN-XL, and then the other buses will come shortly after.
Yes.
Okay, and how is tool support for the layered standard? So I know that the Modelica Association, which of course hosts the FMI development, has been known to also offer lots of betas, so tools can be developed beforehand. Can we use this now? Is the tool support already available for the layered standard?
Yes, so we on dSPACE side, we are supporting with SystemS as an exporter of ECU FMUs, the final 1.0 with CAN support, but also, which is currently also existing, the 1.1 beta version, which supports FlexRay.
Okay.
You can also already use it, and also for sure simulate it in VECUs. And in the future, we will also support Ethernet, so which is currently as an alpha there.
So the exporter also then needs to support the layered standard. What about the simulation tool?
The simulation tool itself also, yes. So typically you got these the native FMI support, and then with your simulator, and then you can additionally pack in these layered standards, for example, the layered standard for bus communication.
Okay.
But it's also possible, because I already mentioned this, these layered standard only use functionality from the FMI 3.0 standard itself. So you can also use a native FMI importer just to simulate such an FMI-LS-BUS.
Okay, but then you don't get the bus simulation.
Yes, there is the opportunity that you have the bus simulation not in your importer itself. This is the way we are realizing it on dSPACE side. That you have the opportunity, for example, to combine it with other dSPACE container like a REST bus container or something else. But it's also the possibility to have that bus simulation as a separate FMU. And then you can pack this all together and simulate it on a generic FMI importer, when it supports that features that are required, like clocks or binary ports or something else.
So it's also very flexible in how you set up and who you buy from and which solutions you use for which task.
Yes, it is.
Okay, yeah. That sounds very clever, actually. I like that. So that was dSPACE, but there are also other vendors involved in this standardization effort. So you've been in a consortium with dSPACE, but who else is involved in crafting the layered standards?
So we are developing inside the FMI group with companies like Bosch, like ETAS, Synopsys, AVL. So big companies that have a lot of SIL background. And, are also interested in that idea of have a better interoperability between the SIL tools of different vendors and the tool from their side. So, and we also show at the ASAM conference in the last year, we for example, we export an VECU FMU with SystemS, so with the dSPACE tool. And then we take it and, for example, simulate it on a AVL simulator or in Silver. This is from the Synopsys simulator. And everything works together. So it was, this was just the idea of that interoperability.
So essentially that means you get to choose which tool to use to create the VECU, and it will run on any simulator.
Yes.
So that's also something that we really needed, right? So that's also probably was a major goal of this initiative, I assume. And how did it feel to work with all those companies? It sounds like a huge group, and working in huge committees is sometimes challenging. Do you have that experience, or do you have specific things that are really also motivating and made you enjoy that work? So share a little bit about the feeling of the cooperation inside this.
I think I liked it very much. I enjoy it. It was also, for me, it was the first time just working in such a constellation, also with so many different companies. And for sure, everybody or every company has its own tool, or sometimes also multiple tools, and their own use cases, and also their customers, and just also wants to see that the use case they really need is mapped into that standard. But all in all, I think the thing, and I think that was a very nice thing, was that we are all interested in that standard just to strengthen this kind of interoperability, just to have the aim to have such a standard that allows this. So, and primarily to solve that problem, at least for the users of the tools.
You felt, in other words, a great common goal, which is to make it easier for the users to exchange VECUs.
Yes.
Probably especially across boundaries of companies.
Yes.
Yeah, I think that's really about time that we got that. And that's it. Sounds really like fun, actually, to do this.
Yes, it was. And it is also in the future.
Yeah. So what's next?
So currently we are working on FlexRay, so I already mentioned, and also we did.
That was the 1.1 beta that you mentioned, right? Yeah.
So which is currently in the phase of we got a kind of cross-check phase. So we produced, for example, with SystemDesk that FMUs that are working with that layered standard FlexRay in that kind, and then we try to simulate it on other simulators just to make sure that it works.
Yeah.
So, and this is currently in that beta stage, in that cross-check stage, and also we are working in alpha. And alpha Ethernet, we are working on that alpha version, which is also, I think, released for, I think, before 2 weeks ago. And there, this alpha means that we are ready, finished with the description, with the first initial description of the layered standard Ethernet. And we are now producing, based on this alpha version we released, the first demo FMUs, which we can try to exchange and try to see if this concept really works.
So let me just reiterate, because I find that really interesting. So we have 1.0 released now, and the major tools already supported. And you said there's a roadmap for the next 18 months to add FlexRay and Ethernet. And for both of those future milestones, there is a draft and the first alpha or beta version available already. So it's not just some idea, but real concrete work going on towards reaching those milestones.
Yes. There's also, you can see on the GitHub page, where also the you can look at the layered standard itself. There's also a roadmap where you can look at our plans.
So the GitHub is the main representative source of information then by now?
Yes.
That's also good. I think it's also very, according to how it should be done in this time. And one more thing, this cross-check that you've been talking about. Could you explain a little bit more about how that works? Is that public? Is that something you do internally? Is that a dSPACE thing from the FMI group? Just explain a little bit more about the cross-check, please.
So the idea of a cross-check is that we do it, the first cross-checks we do it internally, but for sure everybody can take part if he takes part in the FMI design. group. He can also take part in the FMI-LS-BUS development and also can take part in this cross checks for sure. And in the past, we did it like this, that for example, we from the dSPACE side read the specification, we wrote, that's what this alpha means. We wrote this specification and then we try to validate it in the next stage.
Okay.
And so we have clever software developers and then they get the specification, then they implement, for example, the exporter side.
Yeah.
And then the idea is you give this FMUs to another simulator from another company, which is also working on that FMI-LS-BUS topic.
Okay.
And then he does the same thing on the importer side. So he have clever developers and then he got the specification and implement the FMI-LS-BUS. And then you just try if it fits together. And the idea behind this is when this works, the specification must be good because...
So running software is the measure of all things.
Yes.
That sounds great. So what would you tell an engineer, a company, a group that wants to start adopting SIL testing and virtual ECU creation and simulation based on the FMI and its layered standards? Where to start? What would be the main things to consider?
I think firstly you got the standard itself, but also you got a so-called implementer's guide where are clever tips additionally to the standard itself, which tells implementers or users of that FMI-LS-BUS how to do specific things. For example, more details on how arbitration in CAN is handled or something else. So, and the second thing I think it's also very important, we provide demo FMUs. So you got demo FMUs, for example, for CAN or for every bus type that is supported. And then you got it in source code and you can try it out, you can change it, then you can play something around and can simulate it again. And this helps to understand, I think, the standard a lot. Because reading a standard is one thing, but understand it is I think, as an engineer, it's all about trying it out itself.
That's certainly true in many, many ways. Okay, so Benedikt, thanks for all the really interesting insights into also how you work, and I like the cross-check bit quite a lot. Is there something you want to tell to the audience as a maybe last sentence, some call to action to support you maybe in the FMI group? Or is it something where it's just, please use it and that's it?
Yeah, so as I already said, everybody can take part in the FMI-LS-BUS development. So if you are interested or find some things which are not suitable for you, you can just write issues, for example, in the specified GitHub project. Or we also have a discussion tab in that GitHub project. You can take part or just take part in the FMI design group.
Okay, thank you very much.
Thanks for being here.
So, thanks everybody for listening. I hope you also found this as interesting as I found it. And I'm really happy to see also the energy and the drive that the people at the FMI group put into developing this standard that will allow for seamless exchange of virtual ECUs between different companies in the market, suppliers, tier ones, OEMs, etc. So if you have questions on this topic, feel free to contact us. Benedikt is also here and in the FMI group, he's available. And with that, I say thank you and I'm looking forward to your comments.
dSPACE, your partner in simulation and validation.